In this question, we have a trapezoid, and we're asked to prove, given that AD equals 3/5 of BC, this statement. Well, it's good for us that this statement is made in vector form, because it tells us that not only is the length of AD equal to 3/5 of the length of BC, but also that the directions are the same. Otherwise, we couldn't have used this equality sign in between those two vector symbols. And so we know that this is parallel to this. Similarly, we also know that this angle equals this angle by the opposite angle theorem. And we know, because this side and this side are parallel, that this transversal sets up a Z pattern. So this angle equals this angle, and this angle equals this angle by the Z pattern. What that really means, since all three of these angles are equal, is that this triangle up top is a similar triangle to this triangle down below. Now, we want to be able to make a simple statement to start our proof that is definitely true. Well, we know definitely that AC equals AB plus BC. We can write that down. The reason why that's advantageous to us is that these three vectors are all directionally consistent to vectors in the statement that we're trying to prove. Here's what I mean. In the statement that we're trying to prove, on the left-hand side we have AE. AE heads this way. In the left-hand side of the statement that we just made, we have AC. Well, AC is directionally consistent to AE. Okay, so far so good. We're going to get our directions good. We next have 5/8 AD. Well, AD travels in this direction, straight across. Well, we're going to use BC in our statement. BC travels straight horizontally as well. So I think we would agree that AD and BC are directionally consistent. So 5/8 AD right here is directionally consistent with BC down here. And finally, in the statement that we're trying to prove, we have 3/8 AB. That goes down this way. And in the statement that we wrote a moment ago, we have AB itself. And so 3/8 AB is directionally consistent with AB. So this vector is directionally consistent with that one. So what we have is a statement in vectors which is clearly true. AC equals AB plus BC, which has all of the directional components that we want from the statement that we're trying to prove. Well, we'll simply rearrange AC equals AB plus BC to say AC equals BC plus AB. And now what we're going to do is convert the appropriate variables. Now, since AC right here is equal to 8/3 of AE. How do we know that? Well, remember that this side length is 3/5 of this side length. So if this is 3 units long, this is 5 units long, which means the whole thing is 8 units long. So AE is 3 units long, and AC is 8 units long. That means, using simple fractions, that AC is 8/3 of AE. Again, if AC is 8 units long and AE is 3 units long, then AC is 8/3 of AE. 8/3 times 3 is 8. We have BC down here. Well, clearly BC is equal to 5/3 of AD. And how do we know that? Well, we know that because the ratio of these two sides is 3 to 5. So if this is 3 new units long, this is 5 new units long. And so BC is 5 new units long, AD is 3 new units long, and so BC is 5/3 of AD. And finally, AB stays AB. And so we have this statement here. 8/3 AE is 5/3 AD plus AB. Now, you might not recognize it right away, but we have exactly what we're looking for. We have AE and AE, AD and AD, AB and AB. We just don't have the correct numbers in front. But fortunately for us, we see that if we multiply both sides by 3/8, 3/8 times 8/3 is 1, so we have 1 AE. 3/8 times 5/3 is 5/8, so we have 5/8 AD. And 3/8 times 1 is 3/8, and so we can say that AE equals 5/8 AD plus 3/8 AB. So to summarize, we wanted to make a statement where we were directionally consistent. That's what we did here. The statement we were trying to prove was this guy here, so we made a statement which had directionally consistent components in it. Then we wanted to convert these guys to the proper variables, or in this case vectors. So we needed we needed this to change to something in terms of AE, and we needed this to change to something in terms of AD. And then finally we needed the proper magnitudes. And that was a pretty simple step at the end, simply multiplying through by the fraction 3/8.